What is Coulomb damping and vibration and acoustics? Imagine a machine running smoothly until suddenly it starts to slow down and stop, not because of air resistance or fluid flow, but because of a special kind of friction. That's what Coulomb damping is all about. It's a type of mechanical damping caused by dry friction between two surfaces in contact. And like viscous damping, where the resisting force depends on how fast something moves, Coulomb damping produces a constant force that always pushes against the direction of motion. This frictional force depends on the coefficient of friction and the normal force pressing the surfaces together. The coefficient of friction is a number that tells us how sticky or slippery the surfaces are. The normal force is how hard they press against each other. The force from Coulomb damping stays the same in size but reverses direction whenever the motion changes. Think of it like a brake that always pushes back with the same strength, no matter how fast or slow the object is moving. In vibration systems, Coulomb damping causes the amplitude of oscillations to decrease in a straight line over time. This is different from viscous damping, where the vibration decreases exponentially. Because the damping force is not related to velocity, the vibration amplitude drops by a fixed amount each cycle until the system stops moving. The natural frequency and the period of oscillation stay pretty much the same, but the overall motion becomes less intense each time. From an engineering point of view, Coulomb damping is very common. It shows up in many real-world systems like bearings, joints, clutches, and sliding parts. It helps control vibrations and prevents parts from shaking too much, which could cause wear, noise, or even damage. But since the force stays constant, it can sometimes cause stick-slip motion, where parts stick together then suddenly slip apart. This can lead to sudden changes in vibration behavior, which engineers need to consider when designing machines. In acoustics, Coulomb damping affects how vibrations turn into sound. When parts rub against each other or slide, the friction can dissipate energy and reduce noise. Understanding Coulomb damping helps predict how vibrations fade away and how much noise might be generated by machinery or structures. Some key features of Coulomb damping include a constant friction force that opposes motion, a linear decrease in vibration amplitude over time, and no change in the natural frequency of the system. Because the friction force switches direction with the motion, the system behaves in a nonlinear way. It's important to model and account for Coulomb damping in vibration analysis to improve system reliability and longevity. In summary, Coulomb damping is a friction-based damping mechanism that reduces vibrations by a steady, constant force. It's essential for understanding how many mechanical systems behave and how they lose energy over time. Recognizing this type of damping helps engineers design quieter, more durable machines and structures that can better handle vibrations and noise.